हेलो, अस्सलाम वालेकुम। आवाज आ रही है?
वालेकुम
यस।
अस्सलाम सर। यस।
अच्छा जी, आज फिर करते हैं कोशिश इसको। ऐसे मैंने आई सेंड यू पास पेपर्स एज वेल, ठीक है, 1 सेकेंड। अच्छा, चैप्टर जो है ना, वी ऑलमोस्ट डन। अच्छा, जस्ट रिमेम्बर, ये वाला जो चैप्टर है, दिस इज kind of easy in the sense that it is very little to understand actually, and a lot of it, I mean, you get big questions on this, but it's mostly I mean, a lot of it is just memorization, extraction of metals. I mean, there's obviously concept and understanding, but a lot of it is just memorizing things. ठीक है, the whole process of extraction of aluminium, etc. ठीक है, चले यहाँ से स्टार्ट करते हैं। एंड क्या रह गया था इसमें? आई थिंक द ओनली थिंग दैट वाज लेफ्ट, द ओनली लिटिल small thing that was left was we did extraction of aluminium, so we're kind of done with all the extraction of metals. Aluminium में क्या है? हाँ, बस that's it, ठीक है, we're kind of done with all the extraction of metals. The only thing that's left is going to be your decomposition reactions. ठीक है, so we're done with extraction of metals. Decomposition reactions. So decomposition reactions are that metal compounds, they tend to decompose when you heat them. When heated, decomposition means breakdown, right? I said there are three main metal compounds. The first one is a carbonate. So I'm just going to write, ठीक है, CO3 -2 होता है. So metal carbonate, they tend to decompose. They form metal oxide plus carbon dioxide. ठीक है, so when you heat them, that's it. So make sure you know this. So if I have magnesium carbonate, so you heat it, it will form magnesium oxide plus carbon dioxide. ठीक है, that's it. So this is the first one. Okay, metal carbonate, they decompose and they produce metal oxide and carbon dioxide. Second one, just second, that's nitrates. So when you have metal nitrates, they they would also decompose, and when you heat them, and they're going to form metal oxides, and NO2 gas is going to be produced, and oxygen gas would also be produced. NO2 is a brown poisonous gas. ठीक है, that's a brown poisonous gas. So make sure you remember this, कि metal nitrate, when you heat it, it will produce metal oxide, NO2, and O2. और उसका एग्जाम्पल कर लेते हैं, like if I have calcium nitrate, so they're going to decompose and it's going to form calcium oxide. C is +2, O is -2, NO2 plus O2. ठीक है, you can balance it. The two ends are on the left side, so two ends should be on the right side. Oxygen कितने 6 हैं, so over here it's 1 4, that's 5. I just need one oxygen, so that's going to be half O2. So metal oxide, NO2 and O2. That's it. And इसमें ना there's an exception. ठीक है, exception is group 1 nitrates are pretty hard to decompose. If it's a group 1 nitrate, are difficult to decompose, and they don't fully decompose. Example is K, you have sodium nitrate, Na plus 1, NO3 minus 1. If you heat it, then it will, बस उसमें से ना, only there's going to be a tiny amount of oxygen that's going to be produced. That's it. So it will form NO2 minus 1 जो होता है, that's a nitrite. Nitrite. And this one is a metal nitrate. So keep this in mind that group 1, they don't usually decompose fully. ठीक है, is this clear? ये clear है सारों को? हानिया, अहमद, जरार, ज़ैनब, is this clear? अच्छा, और फिर finally you've got hydroxides. ठीक है, metal hydroxides. So they would also decompose and they would form metal oxide plus water. ठीक है, if you heat them strongly. And that's it. And one thing that you also have to remember is that reactive metals always are harder to decompose. So they have compounds. क्योंकि इसको इतना सोचो, a reactive metal wants to form a compound. So a reactive metal will always want to form a compound, so it will be very hard to decompose it or turn it back. So reactive metals have compounds which are difficult to decompose. And they have a higher decomposition temperature. Here they're going to have a lot higher decomposition temperature. So the more reactive the metal is, more difficult it's going to be to decompose it. So remember this. This is probably the last thing, which is that nitrates, carbonates, and hydroxides, they all decompose. And that's it. ठीक है, तो चलो we'll start doing I've sent you a past paper worksheet. So I'm just going to open the same one. Okay, we're going to start doing questions on this. Starting with the first one. That's a question on decomposition. So you've got a carbonate, you heat it. So what's going to happen? It's going to form an oxide, okay, which is going to be SRO. Achha, SR group 2 mein, so that's why it's +2, and oxygen is group 6, so that's -2. So the formula would be SRO. And it will form carbon dioxide. So remember, carbonates will decompose and they'll form metal oxide plus carbon dioxide. So the name of this compound, rubidium with NO2. NO2, remember, is NO2 minus 1. Rubidium is group 1, so that's +1. NO2 is -1. So yaad rakho, NO2 -1, that's nitrite. So this one, it would have been nitrate if it had been NO3. So this one is rubidium. ठीक है, ITE होगा इनमें. अच्छा, the next one is again decomposition. He's decomposing strontium nitrate. So it will form a metal oxide, NO2 gas, and oxygen gas. ठीक है, remember nitrates will decompose and they'll form metal oxide, NO2, and O2. उसको बैलेंस करना है. There are 4 ends on the right side. ठीक है, make sure every equation has to be balanced. यहाँ पे कितने हैं? There's just 2 ends. So I would have to double this. SR is doubled, and you can count the oxygens. That's कितने? That's 6 into 2. That's 12. So you've got 2 oxygens plus 8 oxygens, and then the 2 oxygens. So that's also 12. अच्छा, अगला वाला है कि खैर वो एसिड्स के ऊपर है. The heat causes, yeah, it's again a decomposition question. He says potassium nitrate decomposes. So write an equation for the decomposition of potassium nitrate. Potassium is group 1, K plus 1, NO3 minus 1. अच्छा, मैंने remember I told you group 1 will not decompose fully. ठीक है, group 1 nitrates are harder to decompose. So it's going to form a nitrite and O2 gas molecule. ठीक है, it's not going to fully decompose. Agar group 2 hota, then it would have decomposed fully. If it had been calcium nitrate, which is a group 2 nitrate, then it would have decomposed completely. ठीक है, it would have formed CaO plus NO2 plus O2. ठीक है. अच्छा, name an alloy which contains zinc. What other metal in? So, अच्छा मुझे बताओ कि which alloy contains zinc? क्या होगा? Anyone? जरार, क्या होगा? Which alloy contains zinc? बल्कि alloys बताओ कि apart from steel, what other alloys do you have? जरार, Zainab, Taha, alloys. हानिया को भी बता दो alloy.
The brass,
ठीक है. Remember, apart from steel, there are 2 alloys which you have to remember. One of them is brass. और brass क्या होता है? That's brass and bronze, right? अच्छा, brass is के क्या होता है उसमें? This copper plus zinc. नहीं, स्टील जो होता है वो तो आयरन प्लस कार्बन होता है ना. ठीक है,
brass,
हाँ, ये तो ब्रास ही होगा. और there's another alloy which is bronze. That's copper plus tin. ठीक है, these 2 alloys, although they're no longer pretty much used. So name of alloy to zinc wala, it's going to be brass. And other metal in the alloy, that's copper. I say it was zinc. This is the question on zinc. Remember, we did the extraction of zinc. ठीक है, if you look at the notes, I've sent you the notes as well. तो किधर है? Zinc, extraction of zinc. We, right after iron extraction, ठीक है, we did extraction of zinc, which was reduction with carbon. उसमें क्या करते थे? That you had a zinc ore, which was called ZNS, which was known as zinc blend. Usko you burn it, ZNS was burnt, and it would form zinc oxide and sulfur dioxide. And then what you did was that you reacted it with carbon, and carbon was more reactive than zinc, so it would steal the oxygens and reduce the zinc. Okay, and the zinc metal was extracted by fractional distillation. So यहाँ पे it's about so you're saying the ore is heated in the presence of air. So pretty much everything is given. But you just have to write an equation. All the information is given. That this is heated in the presence of air. So that's ZnS plus O2. अच्छा, ये वाला ना actually syllabus में है नहीं. तो अगर ZnS के ऊपर question आता ना, they pretty much give you all the information. ठीक है. We just did it because you very often get a question on this. So anyways, what is produced? Zinc oxide and sulfur dioxide. And you just have to balance it. ठीक है, वो major use of sulfur dioxide हमने अभी पढ़ा नहीं है. लेकिन if you have studied, it's basically sulfuric acid. You make it use it to make sulfuric acid. That's the next one. Write an ionic equation for the reduction of an aluminium ion to aluminium atom. The reduction का मतलब gain of electrons. So aluminium ions, aluminium is group 3, so it's +3 to aluminium atoms. That means it's gaining how many electrons? It's gaining 3 electrons. Okay, that's reduction. Now, he's saying that the original method of extracting aluminium involved the reduction of aluminium chloride using the reactive metal sodium. So this is what's happening. A more reactive sodium in the reactivity series is more reactive, right? So when you have a more reactive metal, that displaces the less reactive. Uske Cl जो है ना वो छीन के अपने साथ, it's going to connect all the, it's going to steal all the Cls, and Na with Cl is going to be NaCl, and Al will be left alone. And you have to balance this equation. There are 3 Cls, so you're going to have 3 NaCls, 3 Nas, so that's going to be 3 Nas, and that's it. Now we've got this question, how can you extract sodium metal from sodium chloride? So this is about extraction of metals. And he's talking about the very reactive sodium metal. So if we go back, the last thing that we did, okay, these reactive metals that include sodium as well, these ones over here, up till Al, above carbon, they were not, I mean, it was very hard to reduce them because they were so reactive, they were always losing electrons. They didn't want to gain electrons back. Na wanted to form compounds like NaCl. It wanted to form ions. It wanted to lose electrons. It didn't want to turn back into a metal, which is why you normally don't see sodium metal, because sodium is very reactive. It just wants to form compounds. So the only possible way of extracting sodium was the electrolysis of molten compounds. All of these, the reactive ones, the only possible way is electrolysis of molten compounds, not even aqueous. Not even aqueous. If it's molten, Na+1 is going to get attracted to the negative cathode, where the battery is going to give it electrons. And when it gains electrons, it will turn back into Na. So we're going to write that over there. Okay, how can sodium metal be obtained from sodium chloride? So the answer is, it's a 2-mark question, so you have to give some detail. So the first one would be electrolysis of molten NaCl. Okay, that's one. And then you're going to tell them that Na+1 is attracted to the negative cathode, where it gets reduced or where it gains electrons. And you can write the equation. The cathode is going to be giving it electrons and it will turn back into sodium metal. So yaad rakho कि more reactive metals are always formed by electrolysis because they always like to form compounds. So it's very hard to actually get those metals back. So it has to be electrolysis and it has to be molten electrolytes. ठीक है? Ye clear? Is this clear? Hania, is this clear? Taha, Ibad, Nabila, is this clear? Clear? Can you clear? Yeah, is this clear? I said next one is so this is about the whole extraction of aluminium thing, right? Okay, I think in the modern method, aluminium is obtained by the electrolysis of aluminium oxide, alumina. So we're just going to revise what was how was extraction of aluminium done? You took bauxite, that was the first thing, bauxite. And bauxite was the ore which had aluminium oxide, which was alumina. But it was impure. It had other impurities. It had other metal oxides. The good thing about aluminium oxide was that it was amphoteric, which means that, so you had this rock. Okay, so let me draw a shape of a rock. So this is your bauxite. Now you had to extract aluminum oxide out of it, and you had to get rid of other impurities. So the way you did that was that you reacted the rock with NaOH. You tried to dissolve it in NaOH. Aluminium oxide, which was amphoteric, it will dissolve in NaOH, an alkali, and it will form salt and water. The other metal oxides, which were also basic, they would not dissolve in other bases, and there would be no reaction, and you would filter them out. So, and then you did electrolysis of, well, Mayer diagram is like I mean, they've drawn kind of a similar diagram. So all of the alumina was then electrolyzed. So we're going to do it over here. So first thing is, what is the first question they've asked is the major ore of aluminium. So this one is bauxite. That's for 1 mark. And I'm going to do all the reactions over here. So this thing over here had what? It had aluminum oxide, but molten aluminum oxide. It was in liquid state. The temperature was 950 degrees centigrade. They didn't really mention the temperature, but so there's going to be aluminum ions, Al plus 3 ions, and there's going to be oxygen minus 2 ions, right? Uh, so the aluminum ions would, because there's this cathode, which is the container, which is supplying electrons, the aluminum ions are going to get reduced. They're going to get attracted to the negative cathode, and they will gain electrons, and they will turn into aluminum. And what will happen to the oxygen negative ions? They'll get attracted to the positive anode. Okay, so they're going to get attracted to the positive anode because they're obviously negative ions, and they would lose electrons. And they're diatomic, so they would lose how many electrons? They're supposed to lose 2 electrons, but now they're going to lose 4 electrons. 2 oxygen atoms are formed, which will join together to form oxygen gas. So that's your main reaction that's happening. So, so the waste gases are that you're getting oxygen gas, but you're also getting carbon dioxide gas and carbon monoxide gas. So I told you that these anodes are made out of graphite, which is carbon. So once oxygen gets formed, the carbon anodes, they start to burn because of the very high temperature. They start forming carbon dioxide and carbon monoxide, so they start reacting with the oxygen. And where do you get fluorine? Because you were adding cryolite. Cryolite was added into the mixture to lower the melting point so that the aluminum oxide otherwise has a very high melting point. So you were supposed to add Na3AlF6 so you can lower the melting point. But because of that, it also introduced the F-1 ions, which is also diatomic. So that would also get attracted to the positive anode. It will lose electrons, form diatomic fluorine. 2 electrons would be lost. Okay, so those were all the reactions that were happening at anode. Achha, now, so let's say explain, ये मेरे ख्याल से ये अगला part है, this one, yeah. Achha, right now I did this part. Okay, all you have to do is, he's saying explain the presence of these gases in the gaseous mixture formed at the positive. So you just have to explain that. Give me the oxygen negative ions from molten alumina, Al2O3, are attracted to anode. And where he's asking include at least one equation, so you're going to include that equation. ठीक है, वो equation यहाँ पे लिख लो. And you're going to form oxygen gas and 4 electrons would be lost. Then you're going to write that the carbon anode or the graphite anode starts to burn. So you can either just state because your at least one equation part is done. And that produces CO/CO2, right? Where does F-1 come? F-1 is also attracted to anode. And that's from cryolite. Cryolite had F-1 ions. And they also get oxidized at, they also come and lose electrons to the positive anode and form fluorine gas. Okay, just be brief and to the point. That's your 5 marks. Explain the presence of these gases. So we did explain all 4 gases. Okay, carbon anode starts to burn and produces carbon monoxide and carbon dioxide. F-1 is attracted to positive anode. Where does it come from? It comes from the cryolite. And that also loses electrons. And where does the oxygen come in? It's coming from the molten Al2O3. ठीक है ये clear है 5 marks for this. Is that clear? Clear है सारों को कि नहीं clear? Hania, Taha, Zahar, here, is this clear? Zainab, clear है? अच्छा, so but the previous part, yeah, this one, why is, I told you it's always going to be asked, why is cryolite added, right? So you're going to add cryolite, why? Because lowers the melting point of alumina and helps to dissolve it. Because remember, for electrolysis, the ions should be free moving, and they can only be free moving if they are in molten state. So what it does is, so it reduces economic cost. Otherwise, you would need a very high temperature for the alumina to melt. So it reduces economic cost and Al2O3 वो electrolysis वाली बात भी करनी है कि Al2O3, I mean, you have free moving ions, so electrolysis is possible. ठीक है, otherwise electrolysis is not going to be possible. The previous part was about वही वाला part था. The previous part was about okay, the ore is a mixture of aluminum oxide and iron Z oxide, which is basic. Explain how these oxides can be separated. So dissolve the ore in NaOH or concentrated NaOH. What happens? The amphoteric Al2O3 dissolves while the basic Fe2O3 does not dissolve because it's basic. And is filtered out. Okay. So remember, it's a very typical question, but you get big questions. मतलब ये देखो ना इसके, how many marks does this have? It's like really big. It's 2, 4, 6, 7 plus 2, 9 plus 2, 11. Then you have 5. 11 plus 5 is what? 16 होता है? 16. And then there are 3 more. 16 plus 3, that's 19. 19 marks just on extraction of aluminium. So मतलब अब ये सोचो कि किसी ने extraction of aluminium, somebody forgot to do extraction of aluminium. That's almost close to 25% of your paper. So just make sure that the metal chapter, that's very important, ठीक है? Especially because you're going to get very big questions on this. So extraction of iron, extraction of aluminium, ठीक है? Overall, the metal chapter, make sure this is an extremely, and remember, there's very little to actually understand. It's not that difficult as well. ठीक है? अच्छा, why aluminium is reactive? Sorry, aluminium, a reactive metal, is resistant to corrosion. So, क्या थी उसकी reason? Anyone? Why was aluminium not rusting? कोई भी बता दे, anyone. I mean, you can type why does aluminum doesn't rust. ये बात क्या रीजन है इसकी रस्टिंग क्यों नहीं होती? जरार, हानिया, एनीवन? ठीक है, बस वो कोटिंग, इट्स गॉट अ टफ, मतलब वो खाली कोटिंग, इट्स गॉट अ टफ नॉन पोरस अनरिएक्टिव कोटिंग ऑफ Al2O3. अच्छा, the two other reasons why aluminum is suitable for making pots and pans. अब वो resistant to corrosion is done. So two other reasons apart from that. Okay, obviously your pot and pan is not going to rust, but उसने कहा two other reasons apart from that. Number one is कि it's a very good conductor of heat. So it's a very good conductor of heat. And number two, it's got high melting point. So obviously you don't want your pot or pan to melt. So again, next one. You've got now the next one is again you got a big question on extraction of iron. As I remember, extraction of iron, जो है, that was done differently. Okay, extraction of iron, if you go back, extraction of iron was कि वो इससे पहले था extraction of iron. अच्छा, extraction of iron में था कि you had any metal that's below carbon that could be reduced by carbon. Carbon was more reactive. So if you have Fe with oxygen, carbon is more reactive, so carbon would be able to steal the oxygens and it will form carbon dioxide and Fe. ठीक है, तो extraction of iron में के so explain why carbon monoxide is formed higher up in the blast furnace. तो इसमें there were three raw materials which are shown over here. At the bottom, air was pumped in, और क्या होता था? Carbon would start burning and start producing carbon dioxide. And as the carbon dioxide got higher up, it would meet other carbon atoms and it will get reduced to carbon monoxide. So why is carbon monoxide? Because there's less air and more carbon higher up. So the carbon dioxide that is produced, there's more carbon. It's got no other place to get oxygen, so it will steal. I mean, they're gonna just divide oxygen between themselves. As I write the equation for the reduction of hematite by carbon monoxide, so both carbon and carbon monoxide, because carbon is more reactive, they would steal oxygens from Fe2O3 and Fe would be left alone. It will get displaced, it will get reduced. And this case me, he's asking for the equation with carbon monoxide. And so I guess that's it. As a limestone was added so that you could get rid of impurities. The first thing was its decomposition of limestone. So calcium carbonate would decompose and it will form calcium oxide plus carbon dioxide. Then the number one impurity was sand, silica, which was SiO2. That was non-metal oxides are acidic, metal oxides are basic. They would react together and they would form calcium silicate, which is also known as slag. They already told us. And explain why the molten iron and the molten slag form two layers and why molten iron is the lower layer. So iron is a transition metal, so they've got very high densities. So it's a transition metal and it's got very high density. और वो जो slag था ना, slag is low density. So hence it floats on top. And why does the molten iron not rust with air? Because slag prevents it. Okay, you have the molten iron and the slag is coating it. So slag prevents iron from reacting with air. It prevents iron from reacting with. ये इधर बना हुआ भी है डायग्राम में कि the slag is the upper layer. So slag is going to prevent it from reacting with air. अच्छा और क्या रस्टिंग के ऊपर आ गया क्वेश्चन. Name two substances which cause iron to rust. So it's two substances, water and air. So water plus. Explain why an aluminum article coated with aluminum oxide is protected from further corrosion, but a steel article coated with rust continues to corrode. So aluminum के ऊपर जो coating होती है ना aluminum oxide की, that's tough, unreactive, and non-porous. Nothing can go through it. अच्छा, steel article coated with rust, ठीक है, when iron starts or steel starts to rust, so rust is porous and breaks off easily. It's not tough. So water and air can pass through it. It doesn't offer any protection or doesn't really coat it. It's very, very porous. So things can just uh, get through it. अच्छा बाकी ये कि the first method, sacrificial protection. So there's a block of zinc. ठीक है, sacrificial protection was, I mean, you've got a steel pipe, which is basically iron, right? How would zinc protect the iron? Zinc is more reactive. तो पहले तो है कि zinc is more reactive than iron, so it loses electrons easily. Or it oxidizes, थोड़ा सा fancy हो जाए कि it oxidizes easily. So electrons, so zinc is the one that really likes to lose electrons because it's more reactive. And those electrons will travel towards the iron. So electrons travel from zinc. As they travel from zinc to Fe. And what happens is that if they travel from zinc to Fe, and so any electrons that are gained by oxygen or water, even if they're being gained at Fe, they're actually indirectly coming from zinc. So Fe would not be able to lose electrons. And the oxygen and water will directly or indirectly basically react with zinc. But अगर वो यहाँ से भी electron gain करते हैं ना, those electrons are basically indirectly coming from, they're indirectly coming from zinc. And you're not going to have any corrosion. Iron will, in the presence of zinc, iron would not be the one that would be losing electrons. ठीक है? चलो ठीक है, कल कंटिन्यू करते हैं. कल हम करेंगे एटीपी. ठीक है? तो ओके एवरीवन, टेक केयर. इसके मैं सारे नोट्स और लेक्चर्स आई ऑलरेडी सेंड, तो टुमारो विल डू एटीपी, ठीक है? अल्लाह हाफिज।